Learning objectives. At the end of this topic, you will be able to give an operational definition of an acid and a base using the characteristic properties of these substances. Define and identify different types of indicators. Explain what is neutralization. List out the ways of neutralization in everyday life. Introduction.
Ah!
What's wrong, Nadia?
I don't know, Mother. My stomach hurts.
It must be the orange juice.
But I've only had 3 glasses of orange juice.
Well, orange juice is sour, so it is acidic. And you haven't eaten since morning. 3 glasses is a lot to drink on an empty stomach. That's why your stomach is hurting now. Nadia's mother is correct. Orange juice is an acidic drink. Our food and drinks can be acidic or alkaline. How do we identify which food and drinks are acidic or alkaline? Think about this. We can group food and drinks as acidic or alkaline by their tastes. Acidic food and drinks usually taste sour. Alkaline food and drinks usually taste bitter. Here are some food and drinks. Which of these food and drinks are acidic? Which of these food and drinks are alkaline? Why do you say so? Drag the food and drinks to the correct boxes. Well done! Pickles, apple juice and lime juice taste sour. These food and drinks are acidic. The garlic, celery and onion taste bitter. These foods are alkaline. Now, find different kinds of food and drinks. Taste the food and drinks to find out whether they're acidic or alkaline. Record your findings in a table in your exercise book. Click check to see which food and drinks are acidic and which are alkaline. Natural indicators. We cannot taste every substance and find its nature. Special types of substances are used to test whether a substance is acidic or basic. These substances are known as indicators. The indicators change their color when added to a solution containing an acidic or a basic substance. Litmus. Litmus is a natural dye extracted from lichens. Litmus turns acidic solutions red and basic solutions blue. Neutral solutions do not change the color of either red or blue litmus. It is available in the form of a solution or in the form of strips of paper known as litmus paper. How do we identify acidic or alkaline substances without tasting them? These are litmus papers. Litmus papers have 2 different colors: the blue litmus paper and the red litmus paper. We can use litmus papers to identify acidic or alkaline substances. Let's carry out this activity to identify acidic and alkaline substances. You will need 2 ml of lime juice, 2 ml of baking soda in water, 2 petri dishes, 2 pieces of blue litmus paper, 2 pieces of red litmus paper. Pour the lime juice and baking soda into different dishes. Put a piece of blue and red litmus papers into each dish. Observe the litmus papers. Do the litmus papers change color in any of the substances? Record your observations in a table in your exercise book. What can you say about your observations? Discuss this with your friends. Then click on the table. Lime juice tastes sour. It is an acidic substance. The blue litmus paper turned red in this acidic substance. The red litmus paper did not change color in this acidic substance. Baking soda tastes bitter. It is an alkaline substance. The red litmus paper turned blue in this alkaline substance. The blue litmus paper did not change color in this alkaline substance. Here is some cooking oil. Is the cooking oil acidic or alkaline? Put the blue and red litmus papers into the cooking oil to find out. Then observe the litmus papers. Do the litmus papers change color when put into the cooking oil? Record your observations in a table in your exercise book. What can you say about your observations? Is the cooking oil an acidic or alkaline substance? Discuss this with your friends. Then click on the cooking oil. Both the blue and red litmus papers did not change color when put into the cooking oil. This shows that cooking oil is not acidic or alkaline substance. It is a neutral substance. Caution! Some substances can be dangerous and should never be tasted. How do we know if substances are acidic or alkaline? Litmus papers can be used to find out if these substances are acidic, alkaline, or neutral. Here are some substances. Put the blue and red litmus papers into each substance. Observe the change in the color of the litmus papers. Which substances are acidic, alkaline, or neutral? Record your observations in a table in your exercise book. Then click Check to compare your results. The blue litmus paper turned red when put into the grape juice and the soft drink. This shows that grape juice and the soft drink are acidic substances. The red litmus paper turned blue when put into the liquid detergent and bleach. This shows that the liquid detergent and bleach are alkaline substances. The blue and red litmus papers did not change color in distilled water. This shows that distilled water is a neutral substance. Did you get the same result as this? We have carried out some activities with different substances. Tasting the substances. Carrying out litmus paper tests. The result shows that substances can be grouped as acidic, alkaline, or neutral. Let's look at the properties of acidic, alkaline, and neutral substances. Acidic substances usually taste sour. Blue litmus paper turns red when it is put into the acidic substance. Red litmus paper does not change color when it is put into the acidic substance. Alkaline substances usually taste bitter. Blue litmus paper does not change color when it is put into this substance. Red litmus paper turns blue when it is put into this substance. Blue litmus paper does not change color when it is put into this substance. Red litmus paper does not change color when it is put into this substance. Turmeric. Turmeric is used as another natural indicator which is yellow in color. Turmeric paper turns into red when it is dipped into basic solution. Turmeric paper does not change its color with acid. Fill the 2 beakers with water about 20 ml. Add a spatula full of turmeric to 2 beakers. Add a few drops of soap solution to the first beaker. The color should change to a deep red. The turmeric solution is turned to red when drops of soap solution is added to it. It is because the soap solution is basic. Chyna Rose. Chyna Rose is another natural indicator. Chyna Rose solution gives dark pink, magenta color with acid and yellow or greenish yellow color with base. Now let us see a video how a Chyna Rose is used as a natural indicator.
In a chemistry lab, litmus paper is the most commonly used acid-base indicator, but we can use other substances as indicators. We will look at one of the options today. We will use Chyna Rose and test it with a few acidic and basic solutions. We have dilute HCl, lemon juice, sodium hydroxide solution and soap solution. We have prepared Chyna Rose indicator by adding hot water to Chyna Rose petals and leaving it for 30 minutes. Now add Chyna Rose indicator drop by drop to hydrochloric acid. Note the change in color. Now add Chyna Rose indicator to lemon juice. Note the change in color. Now add the indicator to sodium hydroxide solution. See the color change. Now add the Chyna Rose indicator drop by drop to soap solution. Wait for some time. You will see that Chyna Rose indicator turns acidic solutions into magenta red and reddish and basic solutions into yellow.
Neutralization. Universal indicator turns red when added to hydrochloric acid and turns blue when added to sodium hydroxide solution. What happens when the hydrochloric acid is added to sodium hydroxide solution of equal amounts in concentration? What color do you expect to see? The color does not show whether the test tube has an acid or an alkali. Click on the red frame for the close-up into the test tube. Let's recall what is happening. At the beginning, the test tube contained sodium ion and hydroxide ion in equal solution. The color of the indicator shows that there are more of hydroxide ions than hydrogen ions. As the hydrochloric acid is added, the hydrogen ion from the acid will form the water molecule when combined with hydroxide ions in the sodium hydroxide solution. The chloride ions from the acid will form an ionic compound when combined with sodium ion from the sodium hydroxide solution. As a result, there are no more hydrogen ions or hydroxide ions in the solution except water molecule and salt, a new ionic compound, which is neutral. That is the reason why the universal indicator does not detect the hydrogen ion or hydroxide ion in the solution. Such a reaction where an acid reacts with base to form water and salt is called as neutralization. Neutralization in everyday life. Neutralization has many applications. Let's find out. Click on the red button for information. Summary. Let's summarize the topic. Acids are sour in taste. Bases are bitter in taste and soapy to touch. Litmus turns acidic solutions red and basic solutions blue. Substances which are neither acidic nor basic are called neutral. Solutions of substances that show different color in acidic, basic and neutral solutions are called indicators. An acid and a base neutralize each other and form a salt. A salt may be acidic, basic or neutral in nature. Baking powder and baking soda are examples of chemicals used in our everyday life. Find out the differences and similarities. How do they work? Does neutralization involve in the cooking every time these chemicals are used? Present your findings in a very interesting and creative way. Many substances around us are either acidic or alkaline. List 5 everyday uses of each substance on the worksheet. Share your findings with your friends.